Well, I've been fussing with this tender chassis for Leon's engine. He's made this really nice looking tender body, and I thought I had a chassis fit for it, and then I've run into some snags with some other mountings on the inside. You know, how we're going to put all this stuff in here. So I thought I had that figured out, and I went to assemble the doggone thing, and I had the tender trucks too far out. They were too far out. And so if I hold this up, they were like this, out like that, instead of back here where they should have been. So I had to make another adjustment, and I'm printing that part right now. And while I'm waiting for that to finish, this thing finished out. That's pretty good. No supports either. Isn't that amazing? So I was leaning over here looking at this. This is the 300 or 310, right? 310, all-wheel pickup and all that good stuff. And I know on this back piece, you don't see it here, but on the other one, I had overheated this board a little bit with one of my bad motors. Anyway, that heat got in here and melted some of this plastic. And I kind of thinking, you know, this is not, that's pretty tight space back there. And I put this really neat bubble, you know, thinking, you know, like a Vanderbilt, you know, like that. I thought, boy, it'd be neat if I could hollow that out. How could I hollow that out? And I didn't really know how to do it. But by golly, I just did it. I'm making this part in two pieces because of I got shape on both sides and it's hard to do. So I just cut it down the middle. Andy taught me that. So you got two flat surfaces, you lay them down, then you glue them together, and it works like a charm. It really does. I'll turn my light off because, yeah. So I started out with an opening here that was approximately the size of the piece, and of course I drew it, and then I went to cut it, and then I tried to make my thing, and I couldn't, and I didn't realize, oh, I'd only cut the inside. I gotta go, so I had to split it, bring it up, and I copied the sketch over, and then I went in about, I don't know, 2 millimeters or something like that. So my computer's decided to take a nap. So I pushed in a little bit, and I had like a tray, and then I have this feature up here, and this is Fusion 360. I imagine some of you guys know this stuff, but it's called Shell, and it allows you to pick sides and then create a shell, and what you define is the thickness that you want in the wall of your shell. So I created this little tray-like thing about 2 millimeters deep, rectangle, and I picked the back wall and I said shell 2 millimeters. So I wanted to keep the 2 millimeter thickness to the outside wall, and it just went pop. And I'm looking at it, and I'm looking at it, and did it do it? Did it do it? And it did. So now, you see that? Oh, baby. So I can put this on, and I've got maybe 6, 8, more millimeters of width on this. Is the hottest part right here. And look where it is. It's right there. From here to here is the hottest part. So I'm going to have a airflow and insulation and the ability to handle the wiring a little easier and all that stuff. Oh man, I can't get over it. So now I need to print a couple of these guys when I get a chance, when I get closer to Leon's. I can't be working on this other stuff, but I have his. I think I've solved all the problems I need to solve, so I'm going for it. We're gonna put it together and printing this last piece now. I think this will come together. I fitted all of this multiple times. It fits really nice. This came out real well, as you can see. Boom, look at that. Wow, that's nice. I had to move these holes in because the trucks were off center. I don't know how that happened. I must have been working on two different tender types or something. I don't know, but at any rate, we're on it now. Now, while he's printing, and that's going to be a while, I'm guessing, 40 minutes anyway, and it's 4:45. I have time. We are working on a wheel project, Jim Shea and I. And he had the idea. We've been working on ball bearing axles for quite some time. And he had an idea. I think we're going to make this work. That what if we have trouble getting the right diameter? And we have a nice shaft, it's 4 millimeters, and we have a nice bearing, and it fits that pretty good. But we can't adapt it to the wheels. We got problems. Okay, he wants to make the wheel. He wants to make this insert, this hub type. So what he's going to do is he's going to make it out of aluminum. He's going to drill in a size of hole that we need, just exactly the right diameter for the shaft, and then he's going to leave a rim like this all the way around like that, and then he's going to cut into it about 1.5 millimeters. Okay, now he needs that stud right for whether it's a screw or the hanger for the push pull bar, right? So he's going to put that in there. Then he's asked me to see if I can make a 1.5 millimeter template or 3D printed component that could be the insert for the wheel, and leave like right here, leave this opening and leave this. One's this for the shaft, this is for the piece that goes in there, and then print it in a flat black or something, I guess, and then glue it into this aluminum wheel. And then we come up here with our insulator, that would go around like that, and then the rim, the wheel with the rim would be like that, and just build it like we normally would on any flyer, using the flyer insulator and stuff. But this inner wheel here, we'd replace it, and we would get the detail. You see that detail? Looks like spokes, and the spokes on the northern, are circular, so it's a little different shape. But can I do this in 3D, and he can machine this in aluminum, and we put the two together and have a wheel that will then fit on the axle with the ball bearing. And the ball bearing would be inside our chassis, and then the axle would go like that, and this would be on both sides. So the ball bearing would fit on the shaft. It would be a press fit, so it would be interference fit. It would be right there. Then the wheel would be pressed on. There would be clearance, just like they're supposed to be, and the wheel's pressed on. When the drive gear, the gear gets pressed on, all that. So that all of that gets assembled outside. So this could be an idler shaft, this could be the drive shaft, say it's an Atlantic. So we look at the engine upside down. What we're thinking is, it's a little thicker than that, I suppose, probably more like that. At any rate, he thinks we can come along here on an existing chassis and just mill that off. Boom, right there, gone. Then he can trim it out, and then he can enlarge it, whatever he needs, to fit the bearings in. Okay, so the bearings would fit. So then he's looking at this, like this. These would be the cutouts. And then we would bring this axle assembly over here, and it would be pre-assembled. The axle would go like that, the wheels would be here, and the bearings are already on, and you just drop it in. Then you do the same thing for the one with the gear down here, right? So you got the gear, bearing, wheel. Drop that on. Then this part that he milled away, I get to make a 3D printed plate with a couple of screw holes in it. It would be more like that, right? And that just screws down to hold the axle and bearing in place. And that only has to do any work when you lift it up. And when you lift it up, it's only the weight of the axle, the bearing, and the wheels pushing down on it. It's not going to be enough. This will make this very strong, very stiff, heavy duty, plastic, 3D printed. That's the other part we're working on. And poor Jim got sick on me. Poor guy. But he's trying. He's still working it. So my job, I got about 40 minutes left. I'm going to start designing this insert for him. See how well that turns out. I'm going to print some and send them up. He's going to machine the wheel and fit them in and see what he thinks. The wheel's aluminum, so we can either polish that or just paint it black to match the spokes, or make it part of the insulator color. I don't know what we're going to do. Right now we're just trying to get a cost-effective means to get ball bearings on these things, because when I did a ball bearing prototype, ball bearing motor, ball bearing axles, the engine was just so smooth, silky smooth. It just revved up and all. It sounded so nice. And I thought, boy, if there's any way we can do it. So I've talked to him a couple of times, but this time I was like begging, don't say no. Let's talk. Let's figure out how. Don't say no. And he seemed to have been caught at a weak moment, I guess. I don't know, but anyway, that's a side issue. Probably shouldn't have told you, but that's other thing we're working on. I wanted to do Leon's, but I don't know that we're going to get it done in time. Well, I got the printer going. I had to go to some new filament inland PLA Plus. I like PLA Plus a lot. I'm trying to see if I can get it carbon fiber PLA Plus. I don't know. I think you can. Any rate, it's red. I'm going to go to black probably tomorrow, because I know I like red, but Leon doesn't, so he's going to get all his parts in black. All right, that's the update. I thought that was cool. That's pretty neat. That's how we can make shapes, for engines as well as tenders and cars and tankers, and it'd be cool because you could do a tanker in two halves, and they would be, you glue them together and they're hollow and all that. It's pretty cool. Okay, gang, I gotta go later.